Lesson 9-1, Day 2, Graphing Quadratic Functions. Our essential question today is how do you graph a quadratic function? We have 4 new vocab words today, and they're a little bit confusing. The domain and the range are the first two. Back in chapter 1, we talked about how the domain represents all of the possible values for x, and the range is all of the possible values for y. Those things were pretty easy to find in chapter 1 because we were just looking at ordered pairs. We were looking at sets of ordered pairs. Now we're going to be looking at graphs and really expanding our knowledge of domain and range. The next two vocab words we have are maximum and minimum. If A, so from standard form, remember, was y equals ax squared plus bx plus c. So now what we're talking about is the value of a. And what the value of a does is it controls the direction that the parabola opens. And then that controls whether or not there's a maximum or minimum value for your quadratic. So if a is negative, the graph is going to open downward like a frown. And that makes the vertex a maximum, the highest point on the graph. If a is positive, the graph opens upward like a smile, and that makes the vertex a minimum because it's the lowest point on the graph. So maximum or minimum. And then the maximum and minimum, those are going to help us with our range, finding our range, the maximum height of the graph or the minimum height of the graph. They're going to help us out when we figure out our range, talking about the possible values for y. Okay, starting out here, we've got consider f of x equals negative 2x squared minus 4x plus 6. It says determine whether the function has a maximum or minimum value, and then state that maximum or minimum value, and state the domain and range of the function. As a hint, it says we may want to sketch a graph. So I am going to sketch a graph for each one of these. Okay, so looking at our function up here, a is negative 2, b is negative 4, and c is 6. So maximum or minimum. If a is negative, take a look at what you just copied from your vocabulary. When a is negative, our parabola is going to open downward, like a frown. So that makes the vertex the highest point on the graph, so it's going to be a maximum. Now we need to find that maximum. We need to state that maximum value. In order to do that, we need to find the axis of symmetry first, just like we did in the first part of this lesson. So x equals the opposite b over 2a. The opposite of negative 4 is 4, and 2 times negative 2 is negative 4. So my axis of symmetry is x equals negative 1. On my graph, x equals negative 1 is right here. It's a vertical line through negative 1 on the x-axis. Now, to find the rest of the vertex, I am going to need to take that negative 1 and plug it in. So y equals, I plug in negative 1 for each of the x's, and I need to solve using the order of operations. Negative 1 squared is 1. So I do the exponent first. Now I can multiply to get negative 2 and positive 4. And then I can add or subtract. So my y coordinate of my vertex is 8. So my vertex is negative 1, 8, which is right here. Remember, the vertex is the only point that is on The only point that is on our axis of symmetry. Now, to find the domain and range, I want to graph the rest of this quadratic. I'm going to graph the rest of it. So I am going to remind you that the y-intercept is c. So on this problem, the y-intercept is 6. So if I graph the y-intercept right here, I can take that y-intercept, and because I know that my axis of symmetry splits my parabola in half, I know that that y-intercept has to have a point that balances it out on the other side of the symmetry line. So right here is going to be another point that is on our quadratic. Then I can draw the graph like that. Now, the domain is all of the possible values for x. So I want you to think about this equation up here, this function, and I want you to think about the values that we could plug in for x. Are there any restrictions? If we choose a negative number, any negative number at all, can we plug it in and solve it? Yes. What about 0? Can we plug in 0 and solve it? Yes. That gives us 6, our y-intercept. Can we plug in any positive number? Yes. So the domain is all real numbers. We can substitute anything we want for x, and we can solve. So the domain is all real numbers. The range, though, the range is restricted. The y values, we've got this maximum point up here. This maximum is -1, 8. So 8 is the highest value. That's the highest value for y. This graph stops at 8 and then goes back down. So the y values are less than or equal to 8 because 8 is the maximum point. The range is tricky to figure out, much trickier than the domain. So when the vertex is a maximum, you are going to have an inequality starting with y is less than or equal to, when the vertex is a maximum. When it's a minimum, that will change, and you'll see that on another problem. So our next example, same kind of a problem, is the last. A is 2, B is -4, C is -1. First thing we need to find, well, we could look at A first. I'm going to slow down for a second. A is positive, so it means our quadratic's going to open upward, and that means that we're going to have a minimum for our vertex. So let's find that minimum. Axis of symmetry first. X equals the opposite of b over 2a. The opposite of -4 is +4. 2 times 2 is 4. So our axis of symmetry is x equals 1. So +1 this time. So my axis of symmetry is right here. Vertical line through, x equals 1. Next, the vertex. I take the value x equals 1, and I have to plug it in. So y equals 2 times 1 squared minus 4 times 1 minus 1. 1 squared is 1. So 2 times 1 is 2 minus 4 minus 1. So y equals -3. So my vertex is 1, -3. So +1, -3, right here. Then I can use my y-intercept, which is the value of c. So the y-intercept is -1, and I can graph -1 on the y-axis right here, and then reflect it to the other side of the symmetry line. The symmetry line splits it in half, so it's got to have a mirror image on the other side. Then you can draw your graph, like that. The domain on this problem, just like on the last one, the domain is all real numbers. You can put in anything you want for x, and you're going to be able to solve it. This function right here does not have any restrictions on what you can put in for x. You would be able to square, you would be able to multiply, you would be able to add or subtract, so no restrictions at all. The range, on the other hand, the range, y is, on our y-axis, take a look at this point right here. This is our lowest point. The lowest point on the y-axis is at -3. So that means our y values are greater than or equal to -3. The lowest point has a y coordinate of -3. So there's nothing below that. Everything is greater than or equal to -3. Okay, now some of your homework problems just ask you to graph, and we've already practiced that. So we don't have to do the domain range, we don't have to do the maximum minimum, all we have to do is figure out our graph. So a little bit less work, axis of symmetry, opposite of B over 2A, because remember, A is 1, B is 4, and C is 3. So the opposite of B, -4, 2 times A, so -4 divided by 2, x equals -2. So my axis of symmetry goes through -2. Now my vertex, keep the 2 from the axis of symmetry, solve to get the y coordinate. Y equals -2 squared plus 4 times -2 plus 3. -2 squared is 4. Multiplying these gives me -8. So my y coordinate is -1. So -2, -1, right here. And then my y-intercept, remember my y-intercept is C. So in this situation, it's 3. So on the y-axis, +3. And then balance it on the other side. Reflect it across the other side of the symmetry line and draw your graph like that. So axis of symmetry, vertex, y-intercept, and reflect the y-intercept to the other side, and you've got your graph. Another example, A is -2, B is -8, C is -2. Axis of symmetry first, opposite of B over 2A. The opposite of -8 is +8. 2 times -2 is -4. So x equals -2 for our axis of symmetry. Draw the vertical line through -2 on the x-axis. Now we can find the vertex. X is -2. Plug it in and solve it. We have a lot of 2's in this problem. -2 squared is 4. So -2 times 4 is -8. -8 times -2 is 16. So my y coordinate is 6. My vertex is -2, 6. Right here. Then all we need is the y-intercept. The y-intercept is C, so it's -2. On the y-axis, -2 is down here. And then reflect it to the other side of the axis of symmetry.
The custodian, please call extension 6801, custodian 6801.
And draw your quadratic. You should be able to write your summary now. And here are your homework problems. Be careful with the directions. You only have to do what they ask for. So some of the problems require you to graph and others do not. If it helps you to graph to find the domain and range or the maximum minimum, then draw the graph. But you don't have to unless it specifically says to graph.